Okay, welcome. So my name is Thomas Hillen, and this time I traveled all the way to Australia to interview a few interesting people. And my guest today is Ryan Murphy. Ryan, just introduce yourself just quickly.
Hi, Thomas. Thanks for the invitation. So my name's Dr. Ryan Murphy. So I'm a lecturer at the University of South Australia, and that's in Adelaide, Australia.
In Adelaide, so is this far from here? So we are currently in Melbourne.
Yeah, so Adelaide's around an hour by plane,
Yeah,
or around a 9-hour drive.
yeah. Australia is so big, right?
Yeah, so
That's
big.
amazing. Yeah. So Ryan, are you from Australia then?
No, I'm originally from England.
From England? Oh,
Yeah, so I
yeah.
moved to Australia 7 years ago to start my PhD,
Okay.
but originally from England.
So where from England?
Originally from Manchester in England.
Manchester. All right.
Yeah,
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 famous for soccer.
yeah.
No, did you do like your master degree in Manchester then, or?
So I did my undergraduate and master's at Oxford.
Okay.
um, and then spent a few years in industry doing like data analytics
Oh,
type work.
nice. Interesting. Yeah.
And then I wanted to come back to do math biology, so I applied for a few PhDs, and there was one available in Brisbane,
Okay.
so I moved to Australia for that.
So who was your supervisor in Brisbane?
So my supervisor was Matt Simpson
Matt Simpson? Yeah.
and
Right.
Pascal Wensley.
Yeah, I see.
So the first part of my PhD was focused on epithelial tissue dynamics. So looking at how epithelial tissues, which are tissues that line most of the organs inside the body, how mechanisms such as cell movement, in particular mechanical interactions of cells, takes place, and how cell division, cell death, and mechanical cell competition, and then how chemical reactions within individual cells give rise to population level behavior. So that was the first part of my PhD.
Okay.
And then the second part was looking at tumor spheroid experiments. So tumor spheroids are some routinely performed experiments in the laboratory. So they're used to test anti-cancer therapies and try and better understand cancer growth. So I performed some experiments in the laboratory, and we did some nice mathematical modeling and statistical modeling to connect the models to data.
Very nice. Yeah.
Yeah.
And you did experiments yourselves, or
Yeah, so I did something.
you did? So
Yeah.
you got your hands dirty.
Yeah.
Yeah. This is fantastic.
Yeah.
Yeah, it's really good. Yeah. Yeah. Now you said you were looking for PhDs, particularly in cancer modeling, right?
Yeah.
So
yeah.
why were you interested in cancer modeling?
So I took quite a few courses of math biology during my undergraduate and my master's,
Right.
and I always found it particularly interesting, mainly for two reasons. One is the potential impact of your work, so how you can develop mathematical models and connect models to data
Yes.
to try and find some real-world insight. And the second was I'm very interested in mathematics, so it gives rise to lots of interesting mathematical problems which are still yet to be solved. I think there's great potential.
Yeah.
I think there's a lot of progress being made. So I mainly focus on the laboratory-based experiments, trying to better understand how things work in the laboratory,
Yeah.
and then hopefully those ideas can translate forward into more clinical pipelines. So I think there's great potential.
So I think it's building knowledge, right?
Yeah,
That's what you're
building
part of.
knowledge.
Building knowledge,
Yeah.
understanding the processes
Yeah,
better.
yeah.
Yeah, yeah, absolutely.
I think mathematical modeling in particular is a very good way to do that, to provide some mechanistic understanding to complement the experiments
Yeah,
and try and better understand how the experiments work and how you can extract more information from the experiments to try and better eventually try and aim to cure
yeah.
cancerous diseases.
So now in Adelaide, you're in a new environment.
Yep.
And do you think you will be able to maybe do experiments again or work with clinicians?
Yeah, so I'm hoping to work with clinicians at the moment.
Yeah.
I enjoyed my time doing experiments in a lab, but at the moment I'm focused more on developing the theoretical models and the mathematical models
Right.
and the connecting models to data. But in Adelaide, there's quite a lot of great experimentalists. So they have a Centre for Cancer Biology
Oh, nice. Okay.
in Adelaide, which I'm hoping to work with people there. And they have a few other institutes which are, I'm hoping to work with, which
Okay.
have great potential.
So the new environment, new people, how do you get into contact?
Yeah, so it's a good question. So that's something I'm in the process of at the
Yeah.
moment. So some people I've already met in Adelaide from previous workshops and previous conferences. And then there's other people at the moment I'm just kind of emailing just to ask if we can have a chat to see if our research interests overlap. And if they do overlap, we'll see how the
Very
projects
nice,
progress.
right? You have to reach out, right? You
Yeah,
have to go
yeah,
them
have
and
to
reach
reach out.
out and introduce yourself
Yeah,
and
yeah.
see what you do, right? And yeah, and I think the reception is very different, right? There's some people who are really eager to
Yep.
get mathematicians involved, and then others are rather skeptical.
Yep, yeah.
And I think this is fine. Now, Ryan, I want to talk to you about methodology in our area because this has changed quite a bit over the years. So when I started, people would do dynamical systems and PDEs, but this has changed. So now we get much more things about data analysis and also models. Individual-based models have become much more strong
Yeah.
in the modeling. So how do you feel about the modern techniques in applied math or math biology?
I think they're first of all very useful. I think I kind of went through a similar process during my PhD, but on a shorter timescale.
Right.
So I was started off by looking at things like individual-based models and how you can use them to represent tissues, and then derive some corresponding continuum type models.
Right.
But then as my PhD progressed, I was interested more in connecting the models to data and seeing how we could apply these models to real-world applications. So that's partly one of the reasons why I ended up in the laboratory performing experiments, so we can try and get this real-world data and try and connect it with the models.
Yeah, I guess, right?
Yeah, so quite a lot of my work is done in collaboration with different people. So you've got applied mathematicians, statisticians, experimental biologists, and clinicians as well.
Yeah.
So trying to get all of them involved is quite important to try and make sure you're answering not only interesting questions, but questions that can have a real-world impact.
Now, would you have a recommendation for young people who are like maybe thinking doing PhD in math bio, math onco? Should they do it, or how do they go about developing a career?
In terms of tips for kind of searching for a PhD or what you might want to look for, I think one of the important things is finding a good supervisor. I think that's really useful for helping you not only during your PhD but after your PhD,
Yeah.
to try and help you progress. And also finding an interesting project that you can really get stuck into, because
Yes.
a PhD is quite a significant amount of time. So making sure that you find that project sufficiently interesting that you can spend that time on that project.
Yeah. And I think also some dedication, right? And being bold. Like, I mean,
Yeah,
you
yeah.
said you looked around and found something in Australia.
Yeah.
So I mean, this is a big step, right? To go across the world.
Yeah, that
somewhere else.
wasn't my original plan. It was only after it got told to me it could be potentially an opportunity that I decided to move.
Yeah.
But I think the project was, and Australia is a lovely place to live as well. So
Sure,
it's
I
very-
think absolutely, yeah, it is. That's right. Yeah, great. So thank you very much for your time,
Thank you.
for this wonderful interview.
Thank you.